All right, and here's the back of the page and our final page on volume. Um, this is pretty easy. Number 7 here appears the same as one of the ones on front. We got a right triangle for a base. That means I can find the area of that base by using 6 feet and 8 feet as the base and height of that triangle. And the standing height of the shape is 12 feet, so you should be able to find the volume very easy. Don't forget, volume is equal to the area of the base times the height divided by 3. So after you find the area of this triangular base here, this is what I'm talking about, multiply by the standing height h and divide by 3. Okay, so cone, well, we've already looked on the other page and saw a cone as well. This has a diameter of 18 miles, so the r equals 9 miles. And we know that the volume from the other page of a cone was going to be pi r squared times the height, because it's the area of the base, and the base is pi r squared times the height. But we got to divide that by 3 for a cone. And you can go ahead and plug in your r and your h, and you should be able to get that pretty easily. All right, number 9, very similar to the last one. Volume is equal to the area of the base times the height divided by 3 because it's a pyramid. Now, the area of a pentagon is equal to 1/2 perimeter times apothem. So you need to go through here and find the perimeter of this shape and then multiply by that apothem there. All right? And you should be able to finish this one out. Number 10, well, this one's pretty cake. Volume equals the area of the base times the height divided by 3 because it's a pyramid. So you need to find the area of this base. Well, it's a nice little rectangle here for you, so that should be easy enough to find the area of that. Multiply by the height and divide by 3. There you go, bada bing, bada boom. So let's start with some of the word problems. We've got a square pyramid measuring 10 yards along each edge of the base with a height of 6 yards. I've already worked one of these out in the previous page of a square pyramid, so I'm going to skip this one. But if you want one, it's very similar to number 10, except for it's square for a base. Number 12, a pyramid 5 meters tall with a right triangle for a base. Has side lengths of 6, 8, and 10. Okay, so let's go ahead and do this one. This has a right triangle for a base, and I like to do mine upside down. I just draw them better when they're upside down. I don't know why it is. I do. Okay, and then we said the height of this thing. The height of this thing is 5 meters, and the base is a right triangle with measures 6 meters, 8 meters, and 10 meters. So we need to find the area of the base here, which is a right triangle, and multiply it by this height and divide by 3. Volume equals area of the base times the height divided by, and that's the standing height divided by 3. So the area of that base, that triangle, is equal to base times height divided by 3, or divided by 2. Remember, this is a different height here. This is the height of this triangle and the base of this triangle. So that's going to be 6 times 8 meters. The way you know the base and height is that they are at 90 degrees from each other. So you can't use this 10 here because it's not 90 degrees from 8 and it's not 90 degrees from 6. So that's going to be 6 meters times 8 meters divided by 2, which is going to be equal to 24 meters squared for the area of one triangle. And then to do the volume, I'm going to do the area of that triangle base, which is 24 meters squared. I'm going to multiply that by the standing height of this thing, which is 5 meters, and divide the whole thing by 3. Well, 3 goes nicely in 24. Leaves me 8. 8 times 5 is 40, and meters squared times meters is meters cubed. All right. So the cone one, that shouldn't be too bad. You just need to draw it. Draw yourself a little circle. Well, since it's 3D, we're actually drawing an ellipse, but it should look like a circle laid on its side. Okay. And there you go. Go ahead and fill that in and use that handy-dandy formula we've been using back up in number 8. Hexagonal pyramid, man, those are always tough to draw. Okay, so I'm going to draw a hexagon. And remember, when I'm drawing in 3D, I need to squish things. I need to squish things a little bit. So this hexagon is going to be a little flatter. Okay, it's not the prettiest. It ain't. But you notice it's a flatter hexagon. And then I'm going to pick a point down here, and I'm going to draw in my legs. Kind of looks like a diamond ring. I bet you my wife would like me to buy that for her. So, hexagonal pyramid, 11 foot tall. So that means that the standing height is 11 feet. With a regular base, that means that all these are the same, measuring 6 feet on each side, and an apothem, don't forget our little friendly friend apothem here, with a length of 5.2 feet. Okay, so that comes back to that formula. Volume equals the area of the base times the height, but divide by 3 because it's a pyramid. The area of a hexagon equals that 1/2 perimeter times apothem formula. Okay, so 1/2 perimeter times apothem. So that's 1/2 the perimeter. This is a 6-sided shape with 6 feet, so that's going to be 36 feet times 5.2 feet. And this is starting to sound familiar. I think we've seen this same one many a times. 93.6 feet squared. Okay, good. And next, to do the volume, we need to finish this up. There's your area of the base, 93.6. And the height of the standing height of this object is 11 feet. And divide that whole thing by 3. So I'm going to do 93.6 times 11, and then divide by 3, and I'm going to get 1716 over 5, so it's 343.2. All right, 343.2. Oh, don't forget, that's feet squared times feet, which is feet cubed. Thank you, guys, and I'll see you on the spheres packet tomorrow, which should go actually Monday, which should go very, very quickly.